Our third case for factoring is the product sum method. We use this when the coefficient of the quadratic term is 1 and we don't have a special case. So here's an example of that. It's not a special case. We can't factor out a greatest common factor. It's not a difference of perfect squares, and our a value is 1. So we're going to look at how to actually use product sum to factor. In this case, we want to figure out what times what will give me negative 72 and what plus what will give me negative 1. So let me show you what that looks like. So I'm going to think of two numbers that will multiply to give me negative 72 and two numbers that will add to give me negative 1. The only way to get two numbers to multiply to give you a negative is to have one as a negative and one as a positive. And because we need those two numbers to add to give you a negative number, the bigger number has to be negative. Eventually, you want problems like this to be where you can just look at it and you just know what the answer is, like that. But if you didn't know, you could think, okay, well, 1 times 72 is 72, 2 times 36 is 72, so on and so forth. And eventually, you would find that you need to use 8 and 9. And in this case, we need to use positive 8 and negative 9. So 8 times negative 9 gives you negative 72, and 8 plus negative 9 gives you negative 1. And what we do with this is we can immediately look at these two numbers and write our equation in factored form. So we do x plus 8 and then x minus 9. To make sure we did this correctly, again, do a quick mental distribution. You have x times x gives you x squared, x times negative 9 is negative 9x, 8 times x is 8x. We get negative 9x plus 8x gives you the negative x, and then 8 times negative 9 is negative 72. So we've done that correctly. So we've written something from standard form and went straight into factored form. Now if we're asked to actually solve by factoring, we can take our two factors and set them equal to 0 to solve. Or you can just look at it, x plus 8 equal to 0, so x has to be negative 8 and x has to be positive 9. If you can't just look at it, it's okay. Eventually, we would like to get to that point. But if you need to show your work, this is what it would look like. So in this case, we see that x equals negative 8 and x equals 9. You're not always going to get two unique x-intercepts. Sometimes your answer might be x equals 9 and x equals 9. And sometimes your quadratics aren't factorable, right? Like it may look like this and look like the perfect setup for factoring, but it may not actually be factorable. And so you just need to be aware of that. But this is a general idea of product sum. I do want to show you one other way to consider the product sum method. It's the same steps, but just a different way of organizing it. So if you prefer a factor tree, remember we were trying to find factors of negative 72 that would add up to give you negative 1. And this is what I meant by starting from the beginning. Like 1 times negative 72 gives you negative 72, but it does not sum to negative 9, so that doesn't work. This doesn't work. There's a bunch more options that I didn't feel like listing, and we eventually find that 8 plus negative 9 are factors of negative 72 that sum to negative 1. And then you just go straight into the same thing, right? You do x plus 8 times x minus 9, and you use those to find your solutions if you're asked to solve by factoring.